All right, let's look at our last conic section. Let's look at hyperbolas. We're going to look at equations and graphs of hyperbolas. So the geometric definition relies on a cone and a plane intersecting, where the cone and the plane intersect in a completely different way in the opposite direction than they do for a circle. And so this gives us geometrically a hyperbola. The algebraic definition, it's a set of points in the plane such that the difference of the distances from the two fixed points, called the foci, remains a constant. Remember, in ellipses, it was the sum of those distances. Now it is the difference in those distances, and you can see that here. So any two arbitrary points on the surface of the hyperbola, the difference in those distances will remain constant, and we do indeed call that constant c. So we still have a lot of the same things. We still have a center point, we still have foci, we still have vertices. One thing that is going to be a little bit different, instead of a major and minor axis, we have something called a transverse axis, which would be like the major axis, and a conjugate axis, which would be much like the minor axis that we found in the ellipse. And the foci will be inside the two pieces of the hyperbola, just like we found that it was in the parabola. So a lot of things get tied together here on the hyperbola. So here's the general form for the equation of a hyperbola. One thing that we are going to have to watch here, and this will make a difference, since the ellipse has a plus sign here, it really didn't matter which one was listed first and which one was listed second. So we always just listed the x information first and then the y information. Well, now with the minus sign, it matters whether the y term is subtracted or whether the x term is subtracted. And that has everything to do with the transverse axis and that major axis, which direction that it's going to go in. So we're going to have to watch that very carefully when we do our work. So the center is still HK, so that's not new for us. 2A is the horizontal axis, 2B is the vertical axis, and there's a multi-step process for actually graphing these, and that's because we have these two oblique lines, the asymptotes on these hyperbolas that we have to pay close attention to. So in general, here's how we're going to graph these hyperbolas. The very first step, same as always, we need to put it in standard form. We're going to have an x squared term or a y squared term minus the other term squared, and they still have to be set equal to 1. We're going to determine if the hyperbola is opening vertically or horizontally. If x is first, it opens left and right. It opens horizontally. If y is first, it opens up and down, so it opens vertically. And so we'll have to pay attention to that when we go to graph. We will start by plotting the center point. That is going to be the HK that we're so familiar with. Here's H, here's K in that form. We'll plot the endpoints of the horizontal axis, and we'll again move A units to the left and right from the center. We'll plot the endpoints of the vertical axis by moving B points up and down from the center. The line segment that contains the vertices of the hyperbola is known as the transverse axis, and the other axis is the conjugate axis. So that's again going to be equivalent to our major and minor axis that we had in ellipses. We'll now draw a rectangle so that each of the axis endpoints is the midpoint of a side. So we'll draw the rectangle, kind of a box there in the middle that will allow us to see where our asymptotes go through, and you'll kind of see what I'm talking about when we do our first graph. We'll sketch the diagonals of the rectangle, extend them out of the rectangle. That's the asymptotes of the hyperbola. We'll draw each branch of the hyperbola, whether it opens left or right or whether it opens up or down, and then we'll draw it so that it approaches the asymptotes that we found. We're going to use the formula c squared equals a squared plus b squared to help us locate the foci. So in ellipses, we had to pay attention to the relationship between a and b. Here, because it was either a squared minus b squared or b squared minus a squared, but now we're adding those together. So there's just one equation for us to find c, and we'll move left or right or up or down in order to find that value of C. And then we'll label those foci again. We don't have to actually find the foci to plot the hyperbola, but we are going to be doing some examples where it actually asks us to find the foci. So the equation of each asymptote can be found by using the point slope formula. We're going to use the center as the point, and the slope can be found by counting on the graph from the point to the corner of the rectangle. That's why the rectangle is so important. Here is the general form. Depending on whether we have a horizontal transverse axis or a vertical transverse axis. The only difference in them is that it is either B over A or it is A over B. Again, you're going to have a formula sheet that has that clearly on it. So all you have to do is refer to your formula sheet once you determine whether you have a horizontal or a vertical transverse axis, and that will make it that much easier to graph. So let's do an example. Here is a specific hyperbola. It's the quantity x minus 3 squared over 36 minus the quantity y plus 2 squared over 16, and that equals 1. So step 1, put it in standard form. Well, it's given to us in standard form, so we're good to go. Determine if the hyperbola is opening vertically or horizontally. Well, the x term is the positive term. It's the first one that's listed, so that tells us that it opens horizontally. It opens right and left. Now we need to identify the center point. Well, here is h. H is 3. Here is k. K is -2. So the center point is 3, -2. Now we need to identify the endpoints of the horizontal axis, the transverse axis, and that has everything to do with the value of a. Here we can see a squared is 36, therefore a is 6. So the endpoints of that horizontal axis, we're going to add 6 to our x-coordinate. We're going to subtract 6 from our x-coordinate. So 3 minus 6 is -3. 3 plus 6 is 9. That's where we get the endpoints of the horizontal axis. On the vertical axis, that has everything to do with b. Here we can see that b is a value of 4. So we're going to take that value of k and we're going to add 4 to it, and we're going to subtract 4 from it, and that gives us our endpoints, our midpoints of each side of our rectangle that we're actually going to draw. And it turns out that one of these sets of points is actually the vertices of this hyperbola, and the vertices will lie on the transverse axis or the major axis. And so these 2 points right here that are on the horizontal axis, since our transverse axis is horizontal, will wind up being the vertices of this hyperbola. Next, we need to locate the foci, which means we have to find c. Remember, c squared is a squared plus b squared, and so a squared plus b squared is looks like 52, and so that simplifies to for c is 2 square roots of 13. So we're going to add, because the foci are going to be horizontal, that's going to go from our x-coordinate plus 2 root 13 minus 2 root 13, and the equations of the asymptotes, since we have a horizontal transverse axis, then these equations of the asymptotes will look like y equals 4/3 x and y equals -4/3 x. And that's after some algebra has been done to them. That's not the point slope form. And I'm fine if you want to give your equations of your asymptotes in the point slope form. That won't hurt a thing. So now we have everything we need to draw the rectangle. And so we can find the midpoints, and out of the corner of the rectangle, we're going to sketch those asymptotes. And then we know that the hyperbola opens to the right or to the left. So there we go right there. The hyperbola opens to the left. There's this chunk. There's this chunk. The center point is 3, -2. And so we're right there. There's the center point, and we could find the foci and everything else. So there's just a quick example of how we would graph. And again, you're going to have all the formulas and all of the relationships that you need. Come to class next time and we'll practice graphing some hyperbolas.